Okay, in this video, I am going to try to make the chain rule seem not so crazy and show you a few examples. Okay, so let's say we start with the derivative of sine squared of x. Now, the sine squared is really sine of x to the second power. Like we put the little 2 in here. Trig functions are fun like that. We can put the 2 over there, but it's really this. And this is a composite function. This is when you have stuff on the inside of other stuff. So when that happens, and we have to use the chain rule, it's kind of like peeling an onion. So chain rule is so important because it allows us to take the derivative of pretty much every function, but you just have to deal with one layer at a time. So when you're looking at an onion, you can only see the outer layer, and then you deal with that layer, peel it off, and you're done with it, and you go on to the next layer. So you can really only see one layer at a time. So the chain rule, you take the derivative of an outer layer, you leave the inside untouched because you can't even see it, and then you multiply by the derivative of the next layer, leaving the inside untouched, and then you multiply by the derivative of the next layer. You continue to leave the inside untouched until you've taken the derivative of all the layers. So let's try this problem. Sine squared looks like this. So the outer layer is the power. It's to the second power. You would use the power rule here, and you put the 2 there, and you subtract 1. This thing, you don't even really see it. So it just comes along for the ride. So your first step would be 2 times whatever's on the inside to the first power. And now that you're done with that exponent, you move on to the next layer. Our next layer is the sine. The derivative of sine is cosine. And that's your derivative right there. You've taken the derivative of 2 layers. And the outer layer was first, leaving the inside untouched, and then you went to the next layer. So let's do another one. Let's do the same one actually, just add an outer layer. Let's add one more layer to this. So it's the same problem, except now there is the natural log on the outside. The derivative of the natural log is 1 over x, and that's if it's just an x. But in this case, it's the natural log of stuff. So when you have the natural log, the derivative of that would be 1 over that stuff, whatever's on the inside. You don't touch it. Comes along for the ride, and then you move on to the next layer. So the next layer would be the power again. That's the outermost piece. And then the third layer is that sine. Every time we do this problem, it's going to be, the last step is always going to be the innermost piece, which is going to be the sine. The middle layer in this case was the power, and then in this case, the outermost was the natural log. Let's add one more layer. Okay, so now this is the square root function. Square root of a whole bunch of stuff on the inside. So the first layer is technically an exponent because that's to the 1/2 power. So everything on the inside is just going to come along for the ride, and you're going to have that 1/2 on the front, and then you minus 1 and you get negative 1/2. So all of this stuff is untouched. It just comes right along for the ride. We just dealt with the square root piece, and we're done with that layer. We've peeled it away. The next layer is the natural log. Derivative of natural log is 1 over whatever it is, and then we've peeled away the natural log. And now you multiply by the next layer, which again is that square. The stuff inside comes along for the ride. And the very last layer was the sine. So we take the derivative of that. So in this case, there were 4 layers. So we had to take the derivative of 4 things. And until we got to the innermost layer, we never did anything with it. It just comes right along. Okay, let's do another one. Different one. Okay, so how many layers? How many layers do we see? There's the cosine on the outside, obviously. The next layer is the square root. And then the next thing is the e function. And then notice the e function has an x with an exponent. So the last layer we're going to take the derivative of is going to be that exponent. So the outer layer is the cosine. The next layer is the square root. Working in is e. Last layer is x cubed. So when we do the first layer, the derivative of cosine is negative sine. All the stuff on the inside stays the same. And now we're going to multiply. Let's take the derivative of a square root. The stuff on the inside of the square root stays the same. It's just the square root piece. Whatever's on the inside of the square root gets to come along for the ride. And the next layer is the e. Derivative of e is just itself. unchanged, and then you times the derivative of its exponent. So there's your derivative. We're not going to go into any simplifying here. This is a crazy function that's just trying to show you that the chain rule is just derivative of the outside, the inside comes along for the ride, derivative of next layer, the inside continues to come along for the ride until the very end. Okay, I hope that clears it up a little for you.